Assalamu alaikum everyone. My name is Durdiboyeva Dilorom. I'm a student of Tashkent State University of Economics, Department World Economy. So today I'm going to make research on a chosen country, Egypt, an assignment given by our academic skills teacher, Aziz Zikriyoyev. So first we have here 20 criterias for making this research. First one is getting our data from the World Bank Open Data Source. So first, first things first, we need to get our data, World Bank Open Data Source. So now here we have two options, browsing by country or indicator, which is country. So after we have some data here, we can download it in an Excel format shown here. So we open it. Here we need to go to data section here. And firstly, we need to choose the years. Before that, we need to create a new workbook. So we copy it and go to our new workbook and put it by transposing so that we have it in this format. So first country name, then there are first years, then we have some options. So what we need to choose? We need to choose one dependent and 5 or 6 independent variables. So as an dependent variable, I've chosen GDP per capita. You have to look carefully, and and you need to choose GDP per capita in US dollar currency, not local currency. We copy and paste it here. Wait, I'm sorry. I was gonna do this. Oh, I made a mistake, so let's redo this. Copy. Here we go. GDP per capita. And as independent variable, we can choose a lot. For example, population, the most common one. We need to choose population total, not in percentage, not male, not some given ages, but total only. So copy. Paste here. Then export, import. Exports of goods and services, current US dollar. Copy. So that's just a technical work. I don't want to take a lot of your time, so you can continue it in that way. Then we need to delete unwanted sections. delete, delete as well. We need the indicator name, and this row also delete. So, and here we can change the names to more comfortable one. For example, years here, and GDP per capita as GDP per capita, so that it's gonna be comfortable for state application to read it. Then population. Oh wait, population. Expert and others. So you save it and start your research. So then first criteria done, then importing Excel file into Stata and save as TTA file. We are working on Stata 18 application here. It's more advanced one. So here we go to file section here up there, then import, choose import, import, and then as Excel file. So the one I have done before that is here. Then we need to choose this first option. So that's Stata would read the first row as variable names rather than variable themselves. So we've chosen this. Then we need to choose cell range here. Around 65 it was. So we're good to go. So here GDP per capita as our dependent variable, population, goods exports, imports, gross national expenditure, manufacturing, and labor force as our independent variables. So if you're new here, you need to create a new do file by clicking this do. Oh, that's opening that here. By clicking these stars, you are making it known for Stata that these are not comments, rather comment names or other things. So Egypt, do we can do. So and after doing after finishing all of this, you can save it. Right now, I have already done that. That's why no need to redo it. Egypt. While we open it, here you can see the commands written in a more comfortable way so that you don't have to type it every time. First thing we need to do is to begin our log file. We go to file button up there, choose log and begin. You can give it a name. For example, today's Egypt log. And don't forget to choose the log option here. We'll save it at this clock. That's it. So that means we started. And in the process, don't forget to check it. No, don't forget to check it. It must say close. And if it again says begin, that means you haven't began it yet. So let's start executing the commands. First command is browse. Here we have our variables, and as you see, years is given in red. We need to this string, this variable as numeric one. So and another option to give commands to Stata is this command bar. For example, browse and click enter. That's it. That's it. So we've stopped here. We've browsed again. Next command is installing doc file. That is, yes, we already have installed it. So we need to summarize. As you see, we have 64 observations and mean here, mean and standard deviation, how much they deviate from standard standard number, then minimum and maximum points. We open our doc here. So here we copy it and must be this, yes. And yeah, here we've pasted our summarization summary. Next option is to set years. Then we can give this command in one go. After generating these graphs, you can copy it and take it to your Word file. Here, I've already did that. Here, population. Wait. Population, GDP per capita, export, import, and other stuff. So it means over the years, all of them have increased, except for this last 5 or 6 years. There has been some random increase and decrease. So next option, next command we have here is graph matrix. That is alternative for scatter box, two-way scatter. That two-way scatter shows everything individually, and this is a combination of them. We can here GDP per capita and its relationship with population, goods and exports, goods imports, gross national expenditure, manufacturing, labor force, and you got the idea. So we copy it and go to our Word file, and here I have already done that. So next command we have is Pearson pairwise correlation matrix. We need to close our my doc file here. and we need to rerun our command. Execute. So here you see that's Pearson pairwise correlation. That shows how much a correlation, how much they change in a relationship to the other variable. For example, one unit change in years means 0.9 unit change in GDP per capita. If we have stars here, that means all of them are um statistically significant. That means we're okay with them. If we don't have stars, we may consider omitting them. Then our next command is OLS, ordinary least squares model. Don't forget to close my doc file here. Otherwise, it would say this kind of mistake error there. So we execute it. Here, that's the most important part of our research. That's model and residual. Residual is the difference between predicted value and the real value. We have R squared, that is how well this model explains our research. That's 99%. That means it explains it really well. Here, p-value is less than 0.05, our significance level. It means all of them are statistically significant. It means it's going well. We're doing good so far. And I go to my file doc, copy this, and paste it to our Word file, our own Word file. So here is given explanation, in-depth explanation for that. In this research, we are using simple linear formula. For example, like this: GDP per capita, our dependent variable, and independent variables here, and these coefficients we get from running our regression command. Yes, here is that coefficients. That is the amount of GDP per capita we might have if all of these variables here were equal to 0. That is this beta 0 coefficient, and here are given other variables. I've already put the coefficients in their place here. Why do we have a problem here? Can we rerun it? Oh, they are super small, that's why it says 0 there. Then another and what I need to tell right now is I have less time. So we need to check the assumptions of our regression model. The first one is Durbin-Watson. Durbin-Watson test. This statistic checks here I wrote that, I guess. Yeah, autocorrelation. How they repeat each other. So autocorrelation it must be around 2, so that there is slight positive autocorrelation, but I think we're okay. And if you are not sure about that, we can fix it by running Bruce Godfrey command. Bruce Godfrey. So it doesn't reject our HO hypothesis. It says no serial correlation. So it means we're okay. Then STAT hat test for the test for heteroscedasticity. Constant variance. Yes, our variance is constant. That means there is no heteroscedasticity. Doesn't it doesn't increase or decrease in random way, more a constant way, so that there is no heteroscedasticity. And then we need to predict our y hat and e hat residuals. So here we have them. Then we've checked heteroscedasticity and normality of residuals. We need to check. P norm E hat. We check. So it follows a pattern here. There might be slight errors, but that's okay. Then again, test for homoscedasticity. That says also okay. And normality test for E hat. Oh, we need to close our Word file here and rerun the test. Here we have it. The last one. Superior will test for normal data. Then we need to check for multicollinearity. There's no need for sdoc here. We can copy it and run it here. Oh. Stat with, it says 25. If they highly correlate, highly collinear, we can delete some of the variables here. So for that, we need to run a regression again. We need GDP per capita, population. Population and GDP per capita, of course, there is positive correlation between them, so we can omit population here. Then we need export convection labor force. I think Stata. It's gonna do the job. Yes. Wait. If our mean VIF is less than 10, that's better and that's okay, but it would be even better if it were less than 5. So that's end of our research in Stata. So we can determine the logarithm ln. We can generate ln variables as well if we have problems in these tests, but everything was okay, so we didn't do this. So then we need to save our data file. Data file. See, EJ. We'll put 2. Desktop work. That's it. So we've imported Excel into Stata. We've done that. Do file and log file. Oh, we did it. Did I not forget? Close my vlog. Why? I think it's closed already. I'm gonna check it. Analysis. With the word analysis here. that's also plus. Word interpretation plus. So so far our first part of our research is over. Thank you.